we're going back to the moon. But this time, we're not just visiting. For the first time in history, NASA's goal isn't simply to land, plant a flag, and leave. It's to stay, to build, to transform the lunar surface into humanity's first city beyond Earth. A place where astronauts could live for months at a time, breathing air recycled from lunar ice, walking across glass roads melted from moon dust, and working beneath sunlight that never sets. But how do you build a city on a world with no air, no protection, and temperatures that swing hundreds of degrees every day? That's the question NASA and its international partners are racing to answer. And the answers they've come up with might just change the future of life beyond our planet forever. Before we can build a city on the moon, we first need to decide where it should rise. The moon may look small and uniform from Earth, but up close it's a vast and complex world riddled with mountains, valleys, craters, and ancient lava plains. And unlike Earth, it has no weather, no erosion, nothing to smooth the scars of time. Every previous human landing, from Apollo 11 to Apollo 17, touched down near the lunar equator, where the ground was flat, safe, and easy to communicate with Earth. But this time, NASA is aiming somewhere far more ambitious and infinitely more dangerous: the lunar South Pole. Why there? Because this region holds something priceless: water, trapped for billions of years in the shadows of deep craters, frozen solid beneath a surface that has never seen sunlight. These dark valleys, permanently locked in shadow, may contain vast reserves of ice that could sustain life, fuel rockets, and power entire generations of lunar explorers. NASA has already identified 13 potential landing zones along the crater rims and mountain ridges of this region. Each one is a delicate balance between light and shadow, spots that receive just enough sunlight for solar power, but lie close enough to the dark craters where ice is stored. It's a breathtaking landscape, a jagged frontier of perpetual twilight, where sunlight grazes the peaks while the valleys remain frozen in darkness. It's also one of the most treacherous environments humanity has ever faced. Sharp ridges, steep cliffs, and fields of broken rock make every landing a calculated risk. But the reward, if we succeed, is a foothold that could change history. Establishing a base here won't be like Apollo. We can't simply drop a lander, collect samples, and return home. We need infrastructure, the foundation of an entire settlement. Roads, landing pads, energy systems, shelters that can protect astronauts from cosmic radiation, and vehicles that can travel across terrain no rover has ever crossed. The first challenge? Dust. A fine, sharp, electrostatically charged powder that clings to everything: spacesuits, glass, metal, and even cuts through fabric. During Apollo, it scratched helmets and caused overheating in equipment. Now imagine that same dust swirling around solar panels, filling airlocks and damaging life support systems. To build a city, NASA and its partners will have to find a way to tame the lunar dust, stabilize the surface, and create solid ground, a place safe enough to land, build, and grow. Because once the first structure rises from the regolith, once the first road is carved through the lunar South Pole, humanity's presence beyond Earth will no longer be a dream. It will be a reality. And that reality will begin right here, on the frozen rim of a crater bathed in eternal light. Before humans can live on the moon, we have to learn how to build there. And that starts with something as simple and as essential as the ground beneath our feet. Here on Earth, we take infrastructure for granted. We pour concrete, pave roads, and build foundations on solid, forgiving ground. But on the moon, none of that exists. No asphalt, no gravel, no atmosphere, just a fine, razor-sharp layer of dust, a substance so light it floats, and so abrasive it can cut through metal. This dust, called regolith, is one of the biggest challenges for any permanent lunar base. It's everywhere, coating the surface in a blanket of powder that's only a few centimeters deep, but capable of wreaking havoc on everything it touches. During the Apollo missions, astronauts learned this firsthand. The dust clung to their suits like static-charged sandpaper, scratched their visors, and clogged the joints in their helmets. The lunar rovers overheated because their radiators filled with dust. Even inside the lander, fine particles floated through the air, irritating their eyes and lungs. Now imagine that problem multiplied 1,000 times. Dozens of astronauts walking, vehicles driving, ships landing and taking off. Each plume of exhaust would blast dust in every direction, turning the base into a sandstorm of microscopic blades. To build safely, we'll need roads and landing pads, stable surfaces that prevent dust from rising and give machines a place to operate. NASA and its partners are exploring multiple solutions. In the short term, they may use a special spray-on compound nicknamed Rhino Snot by the U.S. military, a polymer solution once used in Afghanistan to solidify desert runways for helicopters. It binds loose soil into a hard, smooth layer, making it perfect for creating temporary pads and pathways. But there's a problem. Every drop of that material would have to come from Earth. Shipping tons of it through space would be costly, and it would contaminate the lunar environment with microplastics. So, engineers are thinking longer term and far more creatively. What if we could build using the moon itself? Scientists at the European Space Agency are already testing this idea through an experiment called PAVER. By using concentrated energy from lasers or focused sunlight, they can melt lunar dust into a kind of solid glass. Once cooled, it forms tough, durable tiles that could be used to create roads, platforms, and protective shells for habitats. It's a simple but revolutionary concept. Turn the moon's dust into its own building material. On Earth, this would be impossible. The energy required to melt sand into glass would be enormous. But on the moon, where there's no atmosphere and gravity is weaker, the process becomes much more efficient. A single high-powered laser or a Fresnel lens, essentially a giant magnifying glass, could focus sunlight into an intense beam capable of melting regolith into smooth, glassy sheets. The challenge is time. According to ESA's estimates, it could take more than 100 days to create a single landing pad 100 square meters wide. That's incredibly slow, but it's a beginning. And once those first tiles are laid, everything else becomes possible. Vehicles can drive safely. Astronauts can work without choking on dust. Equipment can function without being destroyed by the environment. Each small step, each meter of solid ground brings us closer to a functioning lunar base. Because before humanity can rise on another world, we must first give ourselves something solid to stand on, a foundation, forged not from Earth's materials, but from the dust of the moon itself. Once we have stable ground beneath our feet, the next step is to make the moon livable. Landing there is one thing. Staying there is another entirely. NASA's first goal isn't to build a city overnight, but to establish the foundation, literally, for long-term human presence. That begins with the Foundation Surface Habitat, the first lunar home ever designed to support astronauts for up to a month at a time. It's a compact, 3-story structure combining metal frameworks with inflatable modules. The lower level houses the airlock, spacesuits, and a workstation for geology experiments. Above it, an expandable module unfolds to create living space, hygiene stations, and a small biology lab for studying how lunar gravity affects plants and animals. The top level serves as sleeping quarters and a command hub, complete with a medical bay and communication center. It's not luxury, but it's survival. And it's the first true step toward living beyond Earth. From there, NASA plans to expand. Temporary modules will evolve into permanent shelters, protected from cosmic radiation, temperature extremes, and micrometeorite impacts. The solution may come from one of humanity's oldest technologies, bricks. Instead of shipping materials from Earth, engineers intend to use the moon itself. Lunar soil, called regolith, can be heated and sintered into solid blocks, forming walls as tough as concrete without a single drop of water or cement. China has already begun testing this idea through their moonpot vessel concept, an egg-shaped structure built by autonomous robots using 3D printing and traditional bricklaying techniques with simulated lunar dust. Their prototype bricks are currently exposed to the vacuum of space aboard the Tiangong station to see how they withstand cosmic radiation and temperature swings. These are small steps toward a massive vision, an entire network of habitats carved from lunar soil, strong enough to endure decades of occupation. Because if we can build homes here, beneath the eternal shadows of the moon, then every world beyond it suddenly feels within reach. The first human city in space won't begin with skyscrapers. It'll begin with a handful of bricks and the courage to call another world home. Every city needs power. On Earth, we flip a switch and light fills the room. But on the moon, energy is everything, the difference between life and death. For short missions, solar panels are enough. They work brilliantly during the lunar day, absorbing sunlight and turning it into electricity. But the moon's day lasts 2 full Earth weeks, followed by 2 weeks of absolute darkness, 14 days without sunlight, 14 nights of freezing cold. During Apollo, that didn't matter. Astronauts were only there for a few days, but a lunar base, a permanent outpost, can't just shut down for half the month. Solar power alone won't cut it. And that's why NASA's engineers are turning to a different light source, one forged in the heart of atoms: nuclear energy. But before we go nuclear, it's worth understanding just how brutal the moon's environment is. At the lunar equator, temperatures can swing from over 120 degrees Celsius during the day to below negative 170 degrees Celsius at night. No atmosphere means no insulation, nothing to trap or distribute heat. The extremes are constant, and they destroy batteries, electronics, even metal alloys. Now imagine the South Pole, the place NASA wants to build. Here, deep craters never see sunlight at all. They've been in shadow for billions of years. Yet those same shadows hold frozen water, a lifeline too valuable to ignore. So how do we survive in a place where there's both eternal darkness and eternal light? One answer is geography. NASA's Artemis program has identified landing zones on crater rims that receive near-continuous sunlight, up to 90% of the lunar year. Here, solar panels could operate almost non-stop, providing power to nearby habitats in the shadows. But transmitting that energy isn't simple. The terrain is jagged, the distance is vast, and even a small malfunction could cut off an entire base. That's where small modular reactors come in, compact nuclear power plants built for space. The concept isn't new. For decades, NASA has relied on tiny nuclear generators called RTGs, radioisotope thermoelectric generators, to power spacecraft like Voyager, Curiosity, and Perseverance. They use the heat from decaying plutonium to produce small amounts of electricity, enough for a rover or probe, but nowhere near enough for a colony. What NASA needs now is fission, the same process that powers full-scale reactors on Earth. They call it the Fission Surface Power Project, and it's designed to bring the first true power plant to another world. Instead of relying on sunlight, these systems use uranium fuel rods. When the atoms split, they release immense energy as heat, which can then be converted into electricity through specialized converters. No turbines, no steam, just physics turned into power. Each reactor would weigh under 6 metric tons, small enough to fit inside a single lunar lander, and generate between 40 and 100 kilowatts of continuous power. That's enough to run an entire outpost, life support systems, communications, rovers, laboratories, and even early manufacturing equipment. And best of all, they'd work in complete darkness. No sunlight required, no 2-week shutdowns. Companies like Rolls-Royce, yes, the same that builds luxury cars, are leading the charge. They've spent decades designing nuclear systems for submarines and naval vessels, and now they're adapting that expertise for space environments. Their micro-reactor prototypes are astonishingly compact, self-contained, automated, and capable of running for years without refueling. In the long term, multiple units could be linked together to create a lunar power grid, redundant, reliable, and scalable. And they wouldn't just power habitats. They could support fuel refineries, greenhouses, and communication towers, all the infrastructure of a functioning city. But there's another advantage to nuclear power. It could finally free humanity from the limitations of sunlight altogether, because once we master this on the moon, we can take it everywhere, to Mars, to the asteroids, to the icy moons of Jupiter, and beyond. For now, NASA's immediate challenge is to design, test, and deliver the first operational fission reactor to the lunar surface within this decade. A prototype is already under development, and if successful, it will mark the beginning of true independence from Earth's fragile supply chain. Because a city can't survive on hope alone. It needs heat. It needs light. It needs power that never dies. And when those reactors hum quietly beneath the lunar soil, casting their invisible glow through the darkness, it will mean one thing. For the first time in history, human civilization will be alive on another world. So, after all the engineering, the testing, the waiting, what does it mean to build a city on the moon? It means creating the first human outpost beyond Earth's cradle. It means turning a barren world of dust and silence into a place where light never goes out, a place that can sustain life, science, and hope. If NASA's plan succeeds, this won't just be a mission, it will be the blueprint for every world that follows. Each landing pad, each solar array, each habitat module is a seed of civilization rooted not in soil, but in ambition. Imagine standing there, at the rim of a crater near the lunar South Pole, where the sun skims the horizon in a golden haze. Behind you, Earth glows, a fragile blue marble suspended in the void. In front of you, a city begins to rise from the regolith. Pressurized rovers travel across glass-like roads, carrying explorers between laboratories, mining stations, and habitats. Faint trails of light stretch across the surface, solar collectors and transmission lines feeding energy into the core of the base. Inside, oxygen plants hum quietly. Greenhouses glow with filtered light, sprouting the first leaves ever grown on another world. And beneath it all, deep within the shadows, small nuclear reactors pulse steadily, a heartbeat of power that never fades. This isn't science fiction anymore. It's happening, piece by piece, experiment by experiment. Humanity is learning how to live beyond Earth, how to adapt, build, and thrive in a place where nothing was meant to survive. Every new solution, from melting lunar dust into glass, to baking regolith bricks, to generating power from atoms, isn't just technology, it's a declaration, a promise that our story doesn't end here. For thousands of years, humans have looked up at the moon and seen it as unreachable. Now we're designing neighborhoods on its surface. We're talking about roads, homes, and energy grids, the ordinary details of an extraordinary dream. And maybe that's the point, that the extraordinary always begins as something ordinary, a plan, a drawing, a spark of imagination, because once we learn how to build a home there, Mars will be next, then the moons of Jupiter, then perhaps one day, the stars themselves. This isn't just about NASA, it's about us, our persistence, our courage, our refusal to stop reaching higher. We are the species that crossed oceans, that flew across skies, that now looks to carve a life into the void. The first lunar city won't be grand. It'll be small, fragile, a cluster of habitats and lights against endless dark. But one day, generations from now, children will look up from that city's glass domes and see Earth glowing in the distance, their ancestral home. And when that day comes, we'll know that humanity's journey was never about leaving Earth behind, but about carrying its light where no light has ever been before. If this vision inspires you as much as it does us, leave a like, share this video, and subscribe to Stellar Path, because the story of humanity among the stars is only beginning, and together, we'll witness the moment we truly become an interplanetary civilization.